Welcome back to RealClear Radio Hour, brought to you by the Competitive Enterprise Institute. I'm your host, Bill Frezza, happy to spend an afternoon at my old alma mater visiting with Dr. Kerry Emanuel, professor of atmospheric science at MIT and co-founder of the Lorenz Center. Kerry, welcome to the show.
Nice to be here.
Kerry, it's been 6 years now since we first sat down and had a serious talk about your efforts to launch the Lorenz Center at MIT to take a fresh approach to climate science. I asked you on to get an update on your progress, but first I'd like to request a tutorial.
Okay.
And like I told you when I got here, it's been 42 years since I've taken a class in this building. Your center is named after Edward Lorenz, the father of modern chaos theory. I'm hoping to coax you into giving us a layman's explanation of chaos theory without any math.
Oh, sure. Be happy to do that.
Give it a shot.
So, supposing you are hiking in the mountains on a beautiful fall day, and you come across a stream, and it's a turbulent stream, there are eddies in it and so forth, and supposing you go down and you put a leaf in the stream and you follow its course, and supposing you could follow it downstream a few miles, all right? So you do that. It's child's play. It's fun.
Mm-hmm.
Now, supposing you go back and do it again, you put two leaves in the stream that are right next to each other. And you ask, what do you think is going to happen? Well, you can do the experiment. You can go to the stream, and you'll find that initially they're pretty close together, but one might get caught in an eddy at some point, and the other one misses it. And it wouldn't surprise you to know that if you're a few miles downstream, they might be half a mile apart.
But surely if I get the leaves closer and closer together, eventually they'll end up in the same spot, right?
Well, this was the profound aspect of Ed Lorenz's discovery. For some chaotic systems, what you just said is true. For others, it isn't. That is, if you could make the leaves tinier and tinier and tinier and closer together, yes, they'll stay closer longer, but eventually they'll diverge. And there's a distance downstream beyond which
you can't make predictions at all.
You can't make predictions, even if you got them to be one molecule apart, literally.
So this was not in the curriculum when I was here 40 years ago. We were taught to look at deterministic systems, and then we also built models for random or probabilistic systems. We could make forecasts on both systems. How do you make forecasts of chaotic systems? Well,
you can't be on a certain time. So weather is a chaotic system. And if you go outside on a warm, sunny day and you wave your arms around, you're going to be introducing a tiny little perturbation in the atmosphere. And if you wait 6 weeks, it's quite possible that the atmosphere around the whole northern hemisphere would be, in its details, different from if you didn't do that. Now, of course, you're not going to change the long-time statistics of the system, but you might change the instantaneous weather. We don't think it's in principle possible to predict the weather beyond about 2 weeks.
Interesting.
And we can move closer to that limit, and we are. We're getting better at it.
And it doesn't matter how big your computers are, how smart your scientists are, it's just unknowable.
It's intrinsic. It's unknowable. And that's the power of 20th century science, from quantum theory to chaos theories. It actually puts limits on what one can know.
So, Kerry, in 2001, the United Nations Intergovernmental Panel on Climate Change unequivocally stated that the climate system is a coupled, nonlinear, chaotic system, and therefore the long-term prediction of future climate states is not possible. I'm quoting from their report. So if long-term predictions are not possible, why is it that so many people believe 97% of scientists have endorsed cataclysmic global warming predictions?
There's a very interesting way that IPCC statement should be interpreted. What they're saying is that it's impossible to know what the state of the atmosphere will be in its details beyond 2 weeks. That is, I can't sit here, let's say, in the month of December
and tell me if it's going to rain.
And tell you if it's raining on July 10th. What I can tell you, unequivocally, is that with very high probability, it will be warmer on July 10th in Boston than on December 10th. And why is that? It's because we have seasons. And even though there's chaos, the chaos is riding on this wave called the seasons, and we know it's colder in the winter and warmer in the summer. So you can think of it as a chaotic system being driven by slowly varying solar radiation over the course of a year. So the IPCC was not saying that climate prediction is impossible. The IPCC was saying that it's impossible to predict the detailed state of the weather on any given day that far out in the future.
Kerry, satellite-obtained temperature data and Earth station-based temperature data sometimes tell different stories. What do you make of reports that the global warming has hit a pause in the last 18 years?
Well, it did hit a pause for a period of time, and it has before. And what I think it's important to convey is that global warming is not thought to be, and there's no reason it should be, uniform in space. It's not doing the same thing here that it's doing at the equator, or even uniform in time. And the fundamentally most important reason for these fluctuations in time is the ocean. The atmosphere is this body of air coupled to an ocean which is about 1,000 times more massive. Most of the heat that's going into the system because we've put greenhouse gases in the atmosphere is actually going to heat the ocean. And only a little bit it goes to heat the atmosphere. So it doesn't take much exchange of heat between the air and the atmosphere to cause big wiggles in the atmospheric temperature. So if we weren't doing any global warming, if greenhouse gases weren't increasing, we would see nevertheless that the temperature, the global mean temperature, fluctuates on time scales of minutes to decades. And it has in the past and it will in the future. So if you happen to be on the downside of one of those fluctuations, that could temporarily cancel what we're calling global warming.
And speaking of the sea level rise is perhaps the greatest concern for people worried about global warming. A decade ago, forecasts were made that some atolls and Pacific islands would disappear altogether by now, yet many of them seem to be growing. Sea level has been rising since the end of the last ice age, and coastlines shift all the time. Has there been a recent acceleration in sea level rise, or is there any reason to believe that people can't adapt?
Well, of course, you can have acceleration in sea level rise and people can adapt to it. So to answer your first question, sea level rose about 400 feet between the end of the last ice age, about 12,000 years ago, and about 7,000 years ago. And 7,000 years ago, it leveled off. And it was about 7,000 years ago that humans developed civilization and started building permanent habitation cities. We're extremely finely adapted to the remarkably stable climate of the last 7,000 years. Now, sea level is starting to go up again, not nearly at the rate it was doing at the end of last ice, but it has been going up at an accelerating rate, and it's not going up uniformly, and it's not supposed to go up uniformly.
What does that mean?
It's rising very rapidly in the western North Pacific, for example, and it's actually falling south of Greenland. There's spatial patterns to sea level rise.
Is it some kind of standing wave, or doesn't sea level go back to sea level?
No, because of wind. So wind tends to pile up water in certain places and draw down water in others. And as the climate changes, wind changes. Also, the temperature of the ocean is changing not uniformly. So if it warms up more in a certain place, it will expand more. Now, I mentioned sea level sinking near Greenland. That's actually because Greenland is losing ice by melting, losing land ice. And so, believe it or not, that ice, just like all mass, has a gravitational attraction to the water. It was pulling water up. When the ice goes away, that gravitational attraction is less and the water relaxes back down.
Interesting. So what accounts for the growing islands and atolls out in the Pacific if the sea level's going up?
Well, of course, they're coral, and coral does grow. Not very fast, though. So there may be some places where it's been able to keep up, but I think we're all worried about, particularly in the western North Pacific, where sea level has been going up faster than the global average. We're worried about eventually losing some of the islands there.
So, Kerry, take us back around to the satellite measurements, which seem to contradict some of the Earth station measurements. What's that all about?
So, our physical understanding of the system is such that we would predict that the upper atmosphere, about 8 miles above the surface in the tropics, should be warming faster than the surface is. That's just fundamental physics. We don't need giant models to tell us that, although the giant models do that. And weather balloons, which measure temperature above the surface, do show that. The satellite measurements have showed a little less warming in the upper atmosphere than we expected based on physics. That turns out to be at least partly because satellites don't actually measure temperature. They measure the amount of infrared radiation going up space. It's a proxy. And to get temperature, they have to kind of invert this infrared signal to get temperature. When you do that, it's very easy for it to get contaminated by temperature trends elsewhere in the atmosphere. For example, we expect the stratosphere, oddly enough, to cool off because we're putting carbon dioxide in it. And there are other reasons why it might cool off. It is cooling off, and that can contaminate the satellite's rendition of what's happening in the upper troposphere. So that turned out to be part of the problem, but we're still left with the upper troposphere not warming up as fast as we think it should. It's still warming up, just not as fast as we think it should. So we have a research problem in front of us, for sure.
Kerry, the sun clearly plays a major role in climate. Some scientists are predicting the arrival of a Maunder Minimum in sunspot creation. What is a Maunder Minimum, and when they've occurred in the past, what's the impact been on the climate?
So the sun varies. The most clear example of that is it has an 11-year cycle, very well known, very well measured, mostly in the flux of high-energy particles as opposed to light coming from the sun. These are the particles that collide with the Earth's magnetic field and can produce phenomena like the northern lights.
Or interfere with satellite communication or that sort of thing.
Interfere with satellite communication. And it's known that this 11-year cycle also has a small effect on the radiation coming into the atmosphere. So you can have little ups and downs at an 11-year cycle. But there are also much longer-term things. So, for example, in the 17th century, all the Norwegians and others who observed auroras and the early astronomers who had telescopes beginning in the early 17th century, they stopped seeing auroras and they stopped seeing sunspots for the better part of a century. And that coincided with a period in which the temperature was unusually low in Northern Europe. This is when Dutch landscape painters like Bruegel were routinely painting scenes of the Dutch skating on their canals. Well, that doesn't happen today, and it didn't happen even in the 19th century.
And I think it was coupled to the lack of sunspots?
Well, yes, it was a sign that the sun was a little bit quiet. And so, yes, the sun affects climate.
Are we due for one of those?
The science of predicting that sort of thing is very primitive, and the people who do it, I'm not criticizing them, will tell you the same thing.
It's a hard, chaotic problem.
I wouldn't want to venture to say whether that's an accurate prediction.
So if it happens, are we going to luck out and have that cancel out any problems we might have from global warming?
Well, there's a couple of things we don't know. We don't really know whether the cooling of the 17th century was confined to the North Atlantic region or was more global. And it's not clear whether that's enough to cancel out. Even if it did cancel out global warming, it'd just be putting off the problem for a while.
Your particular expertise is hurricanes. 20 years ago, some scientists predicted global warming would unleash a major increase in the frequency and intensity of hurricanes. Has that happened?
Well, there was never a prediction that it would increase the frequency of hurricanes. The prediction that we all agreed on and still do is that we should see a greater frequency of the intense events.
More big ones.
We might even get fewer weak ones. And there are far more numerous weak storms than strong storms. So the two predictions that are robust, and I still think they are, is that higher frequency of the high-end hurricanes and more rain per hurricane. But the signal for that is you're going to have a lot more storms go by in history before we could tease that signal out of the data.
So we need another 50, 100 years of data before we're going to be sure?
Yeah, something like that.
You'll still be here, right?
I don't think so.
Kerry, the Paris Climate Treaty has generated a lot of controversy because of the negative impact it would have on global economies. If every article of the treaty were accepted and faithfully adhered to, what's the predicted impact on global temperatures?
Well, the whole design of the treaty was a first step toward limiting the temperature increase to below 2 degrees C. And if you believe reports like the Risky Business Report commissioned by Michael Bloomberg and Hank Paulson, the long-term damages from climate change that would save would be vastly more than what you'd actually spend to do that. On the other hand, for our generation, my generation, the costs would no doubt exceed the benefits. So the whole game is, do you care about the benefits to your children and grandchildren or only to your own generation?
Well, what discount rate do you apply to the costs?
Very good question. Very good question. The problem is that the it can't be postponed. I mean, if we could postpone action until later, if it were physically possible, if the climate system let you do that, that would be the thing to do from an economic standpoint, but it doesn't.
Wait until we're richer, because it'll be easier to solve the problem.
So I have another take on this, okay? The global energy market today is $6 trillion annually. It's going to be transformed. It doesn't matter whether the United States, it doesn't matter to the world so much whether the United States wants to transform its economy. It's happening in China. It's happening in Russia. China and Russia are building mostly nuclear energy, but some renewable. They're selling it to the rest of the world.
Well, we've switched to natural gas from coal because of fracking.
It helps, but it still emits carbon to the atmosphere. The bottom line is, who's going to take a leading edge in the transformation of a $6 trillion a year economy? If the United States decides it's not going to do that, we're going to be left behind. And that, to us, will be an economic negative, a big one.
Kerry, we had a scientist named Dan Sarowitz on a few weeks ago who wrote quite an intriguing piece called Saving Science, and it's caused quite a few ripples in the community. Up front, he claimed that science is trapped in a self-destructive vortex. He was very concerned particularly about the politicization of science and also its divorce from actual testable products or hypotheses that you can put into the marketplace to see whether your models make any sense. Have you had a chance to look at that?
I did look at the essay, yep.
What did you make of what he said?
Well, it's very thoughtful. I thought it was sort of strongly influenced by his take on biomedical research.
Right. The reproducibility crisis.
The reproducibility crisis. Here's my take on that. I think science, whether it's applied science, like most biomedical is, or pure science, like cosmology, has always proceeded in faltering steps. There have been a lot of bad moves, long before the era of Vannevar Bush.
You mean phlogiston didn't work out for everybody, huh?
Well, for example, there was the hunt for Vulcan. Some people noticed a long time ago, scientists noticed an aberration in the orbit of Mercury. And they thought the explanation for that was another planet. And they looked, and some people thought they found it, and another scientist said, no, you didn't. And everybody's scratching their head until Einstein came along, and it turned out his general relativity explained the aberration of the orbit of Mercury. It's a fantastic story. The difference between then and now is that a lot of the stuff that went on, like the hunt for Vulcan, went on in scientific circles and wasn't really widely known. Now, as soon as a scientist writes anything at all that's interesting, it's broadcast. I think we can be thankful for that for the most part.
Well, and sensationalized, too.
And sensationalized. So, the faltering part of it gets publicized. I don't think scientists are making mistakes and backtracking at a higher rate than they ever were. It's just getting publicized.
Do you think they'll ever find dark matter?
Well, it's dark.
Well, they didn't find luminiferous ether. They looked for that for a long time, too.
So it's easy to make fun of it. I think in the end, you have to recognize that funding science is always a gamble. You're always going to have a lot of false positives. You're going to have science that turns out to be wrong. And the question is it worth it? Is it worth all the wrong stuff so that you get the big advance that happens once in a while that in my view makes up for all that?
That begs the question, worth it to whom?
So this is a very good question. So why do cosmology? I mean, it's almost never going to be worth it to anyone in a tangible sense. But I would say, as the essay did, and I agree with the essay, you fund cosmology for the same reason you fund arts or other forms of entertainment, that it's valuable in a cultural sphere. Nobody would say that, I don't think anybody would say we should get rid of art or symphony orchestras or rock music. It's part of our culture, and exploring and understanding the universe is part of that too. But science also has this other side, the applied side, biomedical research just being one example, where you'd like it to actually make some tangible improvement to people's lives.
I mean, we've been at war with cancer for 40 years now, and there still seems to be a long way to go.
Well, but haven't we come a long way? Haven't we in cancer? I mean, this is something I think was missing in that article, is that your chances of surviving most cancers today are so much better than they were 50 years ago.
It's the old glass half full, glass half empty problem. I went to visit the lab where I did my thesis, and one of the postdocs there has become the director, has been there 40 years now, and I had this conversation with him, and he sits on a lot of these peer review committees, and he acknowledged that probably half the research dollars are funding junk projects that shouldn't be done.
Yeah.
But he saw that as a small price to pay to fund the good projects. That's still $25 billion a year.
Yeah.
That's a lot of money just to make sure we spend some of it well.
Well, you don't want to throw out the baby with the bathwater. And the question is, do you have to have the bathwater? And I think the answer is yes, at some level you do.
So, Kerry, is there a reason to be optimistic about dealing with the climate issue?
Absolutely there is. I think we all look at this mistakenly as, oh, gosh, here's a terrible problem. It's going to be really painful and costly to deal with it. But technology is showing us that that may not be true at all. There's some very, very interesting technical developments. One of them, for example, being the promise that we may someday be economically able to extract carbon dioxide from the atmosphere and bury it, basically. And if we learn how to do, we know how to do that. We just don't know how to do it economically.
Or even in an energy efficient manner. It's not just the economics, it's the energy balance.
But if we can do that, then there's not so much problem with natural gas in particular. Nuclear technology has advanced a long way, okay? And we know, because Sweden and France did it, that we can power up over 10 or 15 years. And not only do that, but solve some of the existing nuclear problems that from the existing technology. We can burn up some of the waste that's been dangerously accumulating on the sites of nuclear power reactors. It's the safest form of energy we've ever generated in terms of lives lost per kilowatt hours generated. It's the lowest. It's lower than hydro. It's lower than solar. It's lower than wind. That's just a fact. You just add up the numbers. Nobody in energy disputes that. And yet it has a bad reputation. Well, we have to sort of try to solve that, and we can solve that by introducing the new generation.
Sure, the pebble bed reactors, the new approaches to building these more safely.
And, you know, if we in the United States can get an edge in those technologies, we can be on the leading edge of the $6 trillion a year energy economy. That would be great, okay? That would be a big economic boon to the U.S. if we can do that.
Well, let's hope we can somehow move away from the demonization of nuclear and kill two birds with one stone, both with the carbon issue and with the energy issue. Kerry, thanks so much for being on the show.
Okay, thank you.
That was Professor of Atmospheric Science Kerry Emanuel over at MIT. Here on RealClear Radio Hour, brought to you by the Competitive Enterprise Institute. I'm your host, Bill Frezza. You can check out RealClear Radio Hour on Facebook or follow us on Twitter at RealClearFrezza. And while you're at it, take a look at RealClearFuture.com for daily updates on the next big wave of technologies. We'd like to thank our sponsor, Old Boston Restorations, for their support. Old Boston is a boutique property management company in Boston's South End. Visit them online at oldbostonrestorations.com. That wraps up our show for this week. Please join us next week, same time, same station. See you then.